Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in today's lecture we will dive into one of the fundamental concepts in probability and statistics, the cumulative distribution function. So whether you are a student, data scientist, AI enthusiast, understanding CDF is crucial for analyzing and modeling data. So let's get started. So first of all, understand what is the discrete frequency distribution. So it represents data where values of discrete random variable occur with specific frequencies. And a discrete random variable that takes countable values and its probability mass function defines the probability of each value occurring. Let us see with an example of cumulative frequency distribution. And the cumulative frequency distribution function is defined or given by fx, and p is accumulated till x, and using summation you can write like this from I to 1 and x is from I till xi. It means that p, that is fx, that is equal to summation, just open the summation p x is equal to x1 plus p x is equal to x2 plus, just write dot dot, and p x is equal to xi. That means you will add all the probabilities till x is equal to I. Now, what is the property of a distribution function? So that is non-decreasing and it lies between 0 to 1. And of course, we will use capital Fx for cumulative frequency distribution. This notation we will use. Now let us see an example. So here x is random variable and it can take values from 0 to 7 and probabilities are 0, 1. If x is equal to 1, so it is 1 upon 10, 2, so 1 upon 5, 3, so 1 upon 5 and so on. But here you will say that it is being accumulated. So here 0 for a 0, thereafter 1 upon 10, thereafter 1 upon 10, in 1 upon 10 you will add 1 upon 5. So we will get 3 upon 10. Again in 3 upon 10, 1 upon 5 will get added and we will get 5 upon 10. The same way we will add and we will get here 1. So that means frequency or probability is being accumulated till x is equal to xi, whatever xi. Now let us see an example. So if I say that xi is equal to 3, so fx, here I should write fx would be p x1 is equal to 0 plus p x2 is equal to 0 plus p 1 2 and p x is equal to 3. So we will add all, thereafter we will get. So here we will get 5 upon 10 finally. So that would be 5 upon 10. So all frequencies we have added 0 plus here 1 upon 10 plus, that means plus 1 upon 5 and 1 upon 5, and after reading we have got this one. So this way, if 5, so we will get this one, we will add all the frequencies. Let us understand continuous CDF or cumulative distribution function. So it can take an infinite number of values in a given range, because we know that between two real numbers there are infinite numbers. We cannot count. And instead of probability mass function, we will use probability density function, and which describes likelihood of x, which will fall within a small interval. You will understand by an example. So let us see that here fx, that is a cumulative distribution function, and instead of summation we will have integration from minus infinity to x, because a random variable is continuous, so we have to use integration, and for a discrete we use summation. And one property that if x tends to minus infinity, so fx would be 0. If x tends to infinity, so that would be 1. Let us see an example. So if diameter x of a cable is a continuous random variable with PDF is given 6x1 minus x if x lies between 0 to 1, otherwise it is 0. So let us see that what is the CDF. So here just integrate the density function from minus infinity to x. So here remember there is no minus infinity. Here we will use 0, because the limit was from 0 to 1. So here lower limit is 0 and upper till x. So here 0 to x, and here this is the density function. If you integrate and put the value of limit, so we'll get 3x square minus 2x cube. And final result, see that the value of CDF is 0 when x is less than 0, and if it is between 0 to 1, that is 3x square minus 2x cube. If x is greater than 1, that means greater than this one upper limit, that would be always 1. So hope you understood the concept.